Let's take a look at the Edexcel Paper 1 Maths paper from yesterday. I've got it right up in front of me. I've not taken a look at it before. Obviously, guys, I can't show you what the exact paper is, but I'm going to go through generally question by question and decide if I feel like it was a tough question or not. Are the comments justified? From what I've seen from yesterday, many students are saying, from question 7 onwards, it got a bit peak. So I'm just going to go through, take a look and give you guys my thoughts. But before I do that, I just want to make it clear that every single year, students always come out of the exam stating that they felt this paper or the paper they just sat was nothing like they've seen before. It's the same story every single year. And I also want to point out the fact that just because online you see a lot of students say that the paper was hard, there's still a large amount of students who don't come onto social media to post about their experience. So there is a silent either minority or majority who aren't saying anything at all. So just be wary of that. In terms of the grade boundaries, guys, nobody knows what's going to happen. Really, you should just be doing the best you can and on every single paper, and don't worry about the grade boundaries. All right. So I'm just going to quickly take a look through. I don't know how many questions there are. Looking at question 1, it looks to be like some transformations of functions, which is a very simple problem. I don't think anybody had an issue with that. Iteration, again, I don't think anybody's having an issue with iteration. We're not even having to differentiate here. You're just rearranging for the x in e to the x, it looks like, because I can see in the iterative formula there's a ln in there. Question 3, pretty simple differentiation of a cubic function. Nothing bad about that. We've got f and g. Say the range of f, really easy, of that quadratic, some composite functions, inverse functions, quite a standard problem. Question 5, the helicopter question. Now, I saw a few comments about the helicopter question. I think some students were talking about degrees or radians or whatever. The figure shows flight path for helicopter. Okay, lands on the ground at A. The flight path is modeled like this, right down the maximum height. Okay, so when t is 0. And horizontal distance 5 is... Okay, so obviously in the question, it hasn't specified whether we are modeling in degrees or radians. Now, I'm very clear with my students on my main course. If there is no degree symbol, the problem is in radians. So from what I see here, this is quite an obvious radians question. Can you make the argument that they should have told you? Maybe, but if you've done enough papers, guys, exam boards have given many questions like this and they have not specified. So if you've done your paper revision, nothing special about this problem. Question 6, integration. Really easy integral that is, just guessing ln and adjusting for constants, and then you've got the solving for p and the limits. Question 7. Okay, so I think this is where students started to kind of break down. I did ask for more context from students in the comments about what it looked like, and it's actually what I guessed it to be about these areas of sectors, about one being, twice as big as the other. This question, guys, is actually very simple. There's actually a question like this in the Edexcel textbook. I've done many of these questions with my main course students, so there's actually nothing alarming about this problem. You got theta in one of the triangles, you'll have pi minus theta in the other. So when you do sine of pi minus theta, it's just the same as sine. You make one equal twice the other. Apply the Newton-Raphson, very simple. The formula is given to you. You just need to differentiate what you got in part A. The only issue I could see with this is that they don't actually give you the answers to P and Q. Now, you will get carried through marks no matter what your P and Q values are. So if you do get your P and Q values wrong, you will get those carried through marks. So it's no real excuse to not go through into part B and gain 1 or 2 marks there. I think you would get 2 marks, to be honest, if you carry through your P and Q and you do the method right. So question 7, nothing alarming. Question 8, summation formula. That's easy, just change it to integral, and then we're just doing integration by parts. So question 8, simple. Question 9, show that, change into sine and cos, expand the brackets, replace it into part B, a very standard question there. Then you would have to, because it'll be in terms of cot, you'll then have to change the cosec squared using your identities. Quite a standard problem. Question 10, what we got here, we got a curve, what looks like a normal Use calculus to find L. Okay, so that you got to do quotient rule or product rule if you bring up the denominator. Find the gradient, y minus y1. Obviously, it's normal, so negative reciprocal. Then find the area. For that, you'd have to integrate that function. Now, that's a standard integral. You could just make a guess. You bring up the denominator, you add 1 to the power just for the constants. So nothing really that bad there. You would obviously have to draw a line down from P and do the trapezium minus the area under the curve. So I wouldn't say that was a difficult problem. 11, R transformations, very simple. Part B, deduce the minimum. Okay, I did all this in my revision stream the day before. In fact, these are all very standard problems. Part C at 3 p.m. Find the value of the constant K. Okay, so increasing at a rate. So on initial observation, you'd have to differentiate what you have in part B. So that D equals, you would rewrite it, differentiate it. And then sub in T is 3 p.m. So 15. Obviously, I'm just doing this off the top of my head, so I've not actually read it properly. But question 11 looks like a standard problem. So nothing so far looks sketchy to me. Question 12, sketch this modulus function, very standard. Sketch k over x. It says y equals k over x. Given that these intersect at 3 distinct points, find in terms of p and q the range of values of k. I can see that one being a tricky one for students. You draw your SIP graph, you're going to have to experiment with how you draw k over x. K being positive means it's going to be in your first and third quadrant. I would have to actually sit down and do that one, but I can definitely see that one as being a tricky one for students, considering p and q are not given, k is not given, but the sketch is the main part of that question. Question 13, we've got a geometric sequence. Common ratio, you do the second over the first, you get the root 2 cos over the sine, so you're going to get the root 2 cot. Then you got the root 3 cot over cos, you equate them, and then you solve. Hence, find the third term. Okay, that's all right. Once you've solved and find the common ratio, that shouldn't be that bad. Many past paper questions on question 13, I think in the IAL papers. Question 14, dx by dt is x a minus t. So that's the separation of variables solved to find the particular solution. Obviously, they're not giving you a, so that's why they've given you 2 sets of information. Find the maximum concentration. Use your answer to B and use the model to answer B and C. So dx by dt, I'm assuming. Find 3SF, the maximum concentration. So you're going to make dx by dt equals 0. You'll get x is 0, which is obviously not what we're interested in because they're asking x is the concentration. So that's not going to be the maximum. So it's when t equals a, then you would go ahead and solve that. Part C is quite standard, just equating. And then question 15 is this proof by contradiction, which I think is the one that students were talking about a lot. So given that you have Pythagoras' theorem, use algebra to prove by contradiction that A and B cannot both be odd. Now, they started off the problem with you. In fact, in the comment section yesterday, you guys didn't tell me that they actually started off the proof for you. So I didn't realize that. They actually told you how to start this off. If they hadn't, you know, you're going to assume that A and B can both be odd. And then they've given you A equals 2n plus 1, B equals 2n plus 1. What's the next logical thing you're going to do? You're going to substitute A and B. You're going to square them. You're going to add them. What you're going to notice is you're going to get an even number on the left-hand side because you're going to square 2 odds, which are odd, and you add 2 odds. It gives you even. So you get C squared is even. If C squared is even, then C is even. Let C equal 2k or something like that. Solve it, then you would form a contradiction. Now, this is the first time I'm looking at this, guys. I'm going to be real with you. This paper does not look as bad as those of you are making it out to be. I'm being real because it's not my job to kind of make you guys, some of you guys who found it difficult, you know, feel better about the situation, because this is just the reality of it, okay? This is a very standard paper. I don't see any issue with anything they've asked. You might be able to argue that they didn't give you the Radians stuff in the helicopter question. Cool. For the rest of the questions, to be honest, very standard. We've seen most of this stuff before. I've not seen that particular contradiction question before, but you're still applying the same logic. And they've actually started off the proof for you. So I don't see anything wrong with that. So my best advice, guys, is if you found it a difficult paper, that's fine. We all find particular papers difficult, okay? It's not the end of the world. You've still got 2 more papers to focus on, all right? So put this behind you. You need to focus on paper 2 and paper 3. Work as hard as you can. I'm going to support you as much as possible by continuing to post videos. Obviously, you can watch as many of my videos as you want on TikTok and on YouTube. I have an A-level playlist which you can go through and watch all of them. But yeah, don't focus too much about what people are saying on social media, because those who struggled, and there will be students who struggled, will complain a lot. I've seen that there is a petition going on online, and when you see what students are writing in these petitions, you know, they're bringing politics into this and all that other stuff, guys. The exam boards are not going to take it seriously if you guys don't take this seriously. So the only thing you can do really now, guys, is put it behind you, focus on paper 2 and then paper 3. And that's really my best advice. If you do have any questions, feel free to DM me. Those of you saying that this was harder than the 2019 paper is not valid. It's definitely harder than the paper that was last year, 2025. In fact, students weren't saying anything after paper 1, but they were saying a lot after paper 2. But in general, this paper was harder than what they set in 2025. But overall, I've spoken to all the maths teachers at my headspace. I've spoken to my friends who are maths teachers in schools across the country, and most of them are saying that actually this paper pretty standard. Okay, so focus on paper 2. I'll see you guys in the next video. And if you guys are interested in my masterclasses, which are happening the night before the exams, covered a bunch of this stuff in those, feel free to head to the link in my bio. Any questions, DM me, and I'll see you guys very soon. Nice.